Okay, I think it's 17:03 here, at least in my time zone. So I think it's a good time to start. So welcome everybody. First of all. Oh, hi Chris. I didn't see you there. Welcome, Chris.
17:03 is the best time zone.
I think so as well. So anyways, welcome everybody to this edition of Academy's Bootcamp spoke presentations, I think they're called officially. So I am here on behalf of PegaSys, and I'll be presenting to you guys today what PegaSys is, what we do, and who we are, and all that. Okay. I'm just going to go ahead and share my screen here. Can I get a quick thumbs up or down if you see my screen? All right, cool. This is not the slide that you're supposed to be seeing at the moment, but this one is. So, you know, there's not many people on the call now, so I would rather this be more of a conversation. And so if anybody has any questions, really feel free to interrupt me. You know, either just raise your hand or just unmute and ask your question. Go ahead, okay? I'd rather this be a conversation than just a monologue on my part. But yes, so as I said, I'm going to be talking about PegaSys today. PegaSys is the protocol engineering spoke of ConsenSys. And what we want is to make Ethereum ready for the enterprise. A bit of context though, my name is Felipe Faraggi. I'm developer advocate at PegaSys. As a developer advocate, I help other developers understand and use a specific set of technologies, in this case, our products. And I also help other developers help us because we do adhere to a very, to an open source philosophy, and we try to build stuff with that mindset. And as such, I help other developers contribute to our project through open source contributions. You can all find me at, well, PegaSys in that Twitter handle here, and then you can find me at this one here and my GitHub handle there. Faraggi is also my handle for our internal, or our rather community rocket chat at PegaSys, which is at chat.hyperledger.org. Quickly, just what we do at PegaSys, our mission, as I mentioned earlier, is to make Ethereum ready for the enterprise. And we do that by focusing on three main, goals. The first one being is that we actually build that, right? We're building software that helps enterprises today use Ethereum. Our main activity, I guess, or our main product is Hyperledger BESU, which is an Ethereum mainnet compatible and private net compatible as well client. We do this by collaborating with Hyperledger and the EEA. I'll talk more about that later. We also have, we understand how enterprises work and what they want and need. So we try to make it easy for them to use these, these software suites or applications, and make it easy for them to interact and use their current tooling and tools with these tools, right? So typically, like we know, for example, key management, private key management is really difficult in general, but it's even more difficult for companies out there because of what stakes are and how hard that could be to manage, right? So we develop tools and plugins in order to be able to interact, or rather for these companies to use their current toolings like HashiCorp, for example, and have them be compatible with BESU. And alongside all of that, we also have quite a big research and development team. It really is research and development, because not only do we focus on researching new subjects and trying to come up with creative ideas on how to overcome difficulties today in Ethereum networks, such as scalability or cross-chain transactions, etc. But also we apply those. We have a team of research developers that are currently implementing those research subjects and actually implementing them into BESU. Also, we have a team that builds an Ethereum 2.0 client, and that kind of has as a goal has a kind of like a proof, a future-proof kind of goal in mind. So whenever Ethereum migrates or evolves into Ethereum 2.0, the clients or our customers today that are already using BESU can easily change from BESU to whatever the new client's name will be, and they'll continue to be able to use the Ethereum network either in Ethereum 1 or Ethereum 2.0 in the future. We believe we're kind of in the intersection of blockchain innovation. We're obviously part of ConsenSys. You all know already what ConsenSys is, but keep in mind that there's more than 1,000 specialists in many countries working in ConsenSys currently. All of them with expertise in blockchain subject matters. We also work very closely with the EA. So the Enterprise Ethereum Alliance, for those who don't know, that is a consortium of more than 500 companies that kind of build the standards on how these companies will be using and interacting with the Ethereum network. And concretely and specifically, what we do with them is that we help write and design the specifications for how the EA's clients should, software clients should be behaving, and we have, I think, 3 or 4 people full-time working on that today, right? I think Pegasus was one of the founding members of the EA as well, and really care about that because we kind of have very aligned mission goals. And I guess more recently, this is a relatively recent announcement, but we are now part of Hyperledger Foundation. So just for those who don't know and might have some confusions about this, Hyperledger is a foundation. It is it was hosted by the Linux Foundation originally, and its purpose is really to create an environment of suitable use of blockchain in the enterprise world, right? In that foundation, there are more than 15 different projects. One of those projects is Hyperledger BESU, which is what we've contributed to that foundation recently. Another project is Hyperledger Fabric, for example, which is, I think, one of the founding members of that foundation itself, and is a project led by IBM. There are many other projects. You can find the whole list of them at hyperledger.org. But yeah, so we are now part of that foundation, and it's important for us because it really is a very open source. I mean, it's an open source foundation, and really they care about that kind of philosophy, and we do adhere to that as well. So it's kind of how we develop our software, and it's important for us to be in that foundation today. These are just some of our partners in our partner network. We have partners that are more platform-based, like Microsoft, Azure, or Infura, Kaleido. We also have development suites like Truffle, which we really work closely with. And we have solutions partners as well, like IO Builders or Atato or Dara. And they basically, they partner with us, and they have their own customers, which they build solutions for, and they use BESU for those solutions, or BESU or other of our solutions or our products. Right, so I've mentioned BESU several times now. What it is exactly is a open source Ethereum client written in Java, and under the Apache 2.0 license. What's interesting about BESU is that it is, as I mentioned earlier, compatible with mainnet. So today you could run BESU and have a node on mainnet. And it has several features on it or integrated into it that help enterprises use BESU to create private or permissioned blockchains. There's many reasons for enterprises to want to be able to make a permissioned or a private blockchain today, and there's also I mean, I think eventually they might move on to public nets, but currently nowadays it is important for that to be an option for enterprises, and BESU gives them that option. We have public and private chain capabilities, as I said. It has permissioning capabilities as well. So you could permission things at an account level, at a node level, locally or on-chain. I might get more into detail of that permissioning aspect later on if there's time. And there's also privacy. We have off-chain privacy and soon, trademark soon, on-chain privacy. It's stable. It's a clean code base. It's easy to read and follow. And if you go to our GitHub, you'll see that it's pretty much very straightforward. There isn't any like magic behind the scenes going on. It's very straightforward. It's a very clean data code base, which is great for developers and for enterprise developers to kind of take a look at before checking it out and seeing what they're working with. And yeah, it has several like simplified deployment and monitoring options integrated into it already. So just as a quick note, we also have Pegasus Plus, which is the service we provide. So we build 100% open source tooling or tools, but we also provide support and service and some additional non-open source tools that can be built, that can be added on top of that BESU base, basically. Those extra features are enterprise features, so they wouldn't normally be used by regular users, but they could include, and they do include, sorry, database encryption, advanced node monitoring to see really all the events and have event streaming with Kafka and ConsenSys, etc. Really, these are kind of features that we think enterprises could use today, and that they do use today. So, I think it's important to show the roadmap because of two things. First of all, as you can notice here, we used to be called Pantheon. We recently changed that name, and that's when we became, and we contributed our code to the Hyperledger Foundation. So since basically October 2019, the project is called, the main product we make is called Hyperledger BESU. And as you can see, we have a very active feature addition to the main code base. And one of the interesting things to note is that we've recently launched the event streaming, as I mentioned already, and we'll have in 1.4, which is February next year, flexible privacy groups, which are great. And I'll talk about maybe in detail as well if we have more time further on. Some use cases are what we've been working on with IO Builders, which is they've been building ZarX, a settlement system. I think this is based out of South Africa. They basically use blockchain to build a distributed settlement system on top of BESU. One of those classic, let's say, fintech kind of use cases, which are great, right? Which are the ones that are being built out today, and the ones that are kind of requiring more attention from real world use cases. We also have LiquidShare, which is a capital markets platform. So you can buy and sell and trade equity shares of small and medium companies. Again, fintech, kind of like typical use cases. This is what we've been seeing as the most demanded for use cases out there today. And supply chain with Trium's product and built by Platform 6. So if you don't know Trium, also a ConsenSys spoke and product, you can go check their website out. What's interesting to know about LiquidShare in particular is that we've kind of been building some of the features on top of BESU along with them and from their requirements. So again, partly on this kind of support level and also as an open source initiative and taking advice and ideas from the open source community. Yeah. So does anybody have any specific questions until now? I think before diving into, like deep diving into features, I might open the floor for specific questions. Anybody might have? So I
have a question. Can you explain, like, in a broad sense, what exactly is the BESU client and what it does for your corporate clients?
Sure. You know what? That's perfect segue to this next slide. And just as an aside, and before answering the question specifically, just note that we don't only have enterprise clients, right? I mean, or rather, we don't only have enterprise users. We also have just regular users like you and me who could run BESU at home as a Ethereum node, okay? But to answer your question, that's what it is. So a client, I mean, I think all of you are software developers out there, but just, bear with me. A software client, the client is actually the software that's going to be communicating or allowing your computer to communicate with a computer or dApp or any kind of transaction to be communicating with the Ethereum network, right? It has several main features, I would say, but the basics of it is that an Ethereum client is going to first, sync the blockchain, the current state of the blockchain onto your computer, onto your node, and then it's going to start receiving transactions and validating those transactions, and if they are valid, adding them to a transaction pool, and then again propagating it to other nodes out there. So the way a regular user could use this at home is just installing the software, running it on his computer 24/7 as a Ethereum node, right? Helps decentralize the network, helps you also eventually not have to trust third-party or other nodes out there. You'd have your own node in which you can propagate, send your transaction to for it to propagate it to other nodes, etc. The way enterprises could use this and use this currently is specifically for creating permissioned or private networks, right? So let's say, for example, we have a consortium of 5 big enterprises, and they all want to share information between them, but nobody wants to trust one single source or one single enterprise or company to hold that data and to store that data, because they could, first of all, basically cheat and modify that database or not accept transactions for somebody, etc. So in this case, that consortium creates a private or permissioned blockchain. They all have access to that data in real time. They can all publish data and know if that data was published by X person, right? Because they have that cryptographic proof that transaction was made by that account. And it has all the benefits of being, in terms of security and in terms of reliability and redundancy. It has all that like nice blockchain features additionally to it. So basically it could act as a mutual shared trust database between several big, parties. And what's interesting is when you start to add small parties into that mix, because sure, big companies might not trust each other, but what's your recourse as a small actor in a group of big ones as well? And that's when maybe it becomes even more interesting, right? So that's the kind of use case we've seen BESU being used for and built on today. Consortiums, private or permissioned blockchains, and being able to use those private or permissioned blockchains in order to, and also cross-post like several like checkpoints of that blockchain onto the mainnet, for example, just to make sure that that's kind of up to date.
Gotcha. Thanks.
Right,
and just briefly, so
sure.
Say that BESU didn't exist today. How would these companies go about building a consortium on Ethereum?
Okay, great question. So we're not the only ones that do this. There's several other clients out there, Ethereum clients. I guess the main one being, if you could call it that, is Geth. So that's the client being built by the Ethereum Foundation. It's the official client, I guess. It's being built by the whole community, but it was initially built by them, and it's kind of maintained by the whole Ethereum community. Then there's Parity, which is built by them. It's Parity. Parity Ethereum is the name of the client, I think officially. It's being built by that company itself. And then there's other solutions out there like Quorum and Hyperledger Fabric, and they all allow you to do kind of the same things as BESU, but BESU has some additional features built on top of that. As I mentioned, permissioning and privacy capabilities, the fact that you can actually communicate directly with the public Ethereum mainnet as well. At least that's compared to Quorum and Fabric, etc. In terms of comparing it to, say, Geth or Parity, one of the main advantages is the license, which is something maybe you can. I mean, it's a super important deal for companies to have and to use open source software that actually aligns with their legal requirements. And Geth and Parity are both built on GPA v3 license, and it's did I say GPA? GPL v3 license, and that's very, very difficult to work with in an enterprise environment. The fact that we're Apache 2.0 is actually is a huge difference. And legal teams on enterprises will basically kind of block any usage of GPL v3 open source software at companies, whereas Apache 2.0, you can even like use or use an Apache 2.0 licensed project and then patent it yourself. So it's very, very open to using it in any kind of way at all. And there's other differences. We have resources out there in literature that kind of talks about that specifically. But to go back to what the client does is, oh, sorry, did I answer that question correctly?
Yeah, I was just going to say thank you very much. That answers very, very well.
All right, cool. So basically what the client does, more technically speaking, is, well, it has these like three main, or four, let's say, main layers, I'd say. So the JSON RPC API and the GraphQL API today are kind of what's going to be receiving the transactions, right? Either from dApps or wallets, or specifically just from your command line or anywhere, basically a terminal. And then there's the storage, the Ethereum core and networking like modules. Storage is where the blockchain is actually stored, all the transactions and all the data is stored. So the whole world state and your local state as well. The Ethereum core is everything that really corresponds to how Ethereum works itself. There's the EVM, like our implementation of the EVM in Java, the consensus mechanisms, both proof of work or all of the following: proof of work, click, IBFT2, IBFT1, all of those are pluggable into BESU today. So you could just basically change your Genesis file and it'll use another consensus algorithm, which is great because typically, enterprises would rather, at least in their, private environments, would rather use click or IBFT2 than an actual proof of work consensus algorithm, which isn't very interesting for private nets. It gives us several advantages between, among them, speed, TPS, etc. And then the networking layer, which is basically dev P2P, again, that protocol thing and how it syncs with other clients, how it's going to discover other clients out there in order to propagate transactions, etc. You can learn more about this in detail. There's a video out there. I might send you guys a video later on, but there's a lot of detail on how the architecture is built behind BESU. Yeah, so again, fully compatible public mainnet. That's what like we strive for. Basically, is Ethereum mainnet to be used. Again, companies out there might need and see the need for private nets, but public mainnet is our kind of main final goal. So privacy in BESU is implemented through a is through another repo or project we call Orion. Orion is our private transaction manager. So really it kind of allows us, it's basically, as it shows in this image here, it's basically like a sub-network or something that's running alongside our Hyperledger client. And whenever we receive a transaction on BESU that is marked as a private transaction, this is going to be passed on to Orion, and Orion is going to see who it sends that to. And in this way, we can allow Alice to send a transaction to Bob without Lisa looking at that information or just kind of snooping in that into that transaction. As I mentioned earlier, we also have privacy groups, which allows us basically to name our groups and our privacy groups in order to kind of send one transaction to a specified group of people. And so all of those persons or nodes are going to receive that transaction, and the people who are, or the nodes that aren't in that group aren't going to receive that. A little bit more in detail, the way this works is that your DApp or whatever sends a transaction to the JSON RPC API. The private transaction handler determines that it's a private transaction, and it sends it to Orion. Orion then determines what remote Orions are going to have to receive that transaction. So based on who is in each privacy group or who's targeted in that private transaction, and then it's going to be sent to that remote BESU client, right? And it itself is just going to transact. It's going to process that transaction, and it's going to publish a public state onto that public blockchain. And then the actual private data is going to be processed and added to a private storage that's assigned to each privacy group. So permissioning usually gets kind of confused with privacy, and they're completely different things. So permissioning really is assigning rules to who can or can't interact with the specific network, right? So in BESU, we have, as I mentioned earlier as well, we have account permissioning, node permissioning, and we have on-chain permissioning and local permissioning. Let's start by talking about the last one. So local permissioning is whatever affects our actual machine, right? Our node, our physical metal node. What transactions, or rather what accounts or what nodes can or cannot send transactions to that node specifically, right? And we can modify those permissions by, via configuration files, via an RPC JSON call, or there's another way to do it, but basically we can modify permissions on that node at a machine level, right? It's going to allow other nodes to, it's going to block other nodes from receiving, or it's going to block our node from receiving transactions from other specified nodes. Then there's on-chain transactions, or permissioning, sorry. And that's going to affect the whole network because it's basically maintained by a smart contract. So whenever we modify the permissions on that smart contract, as long as the nodes are synced and up to date, they won't accept transactions from whatever is determined in that smart contract. So it's a way to, instead of dealing with one node per node and really modifying your specific node to accept or not transactions from determined nodes or accounts, it's a way to do that holistically throughout the whole network, right? It has advantages and disadvantages. It might be slower to propagate because you are, at the mercy of the network updating that smart contract, and for that it needs to have ConsenSys and all of that. Whereas local configurations you can just do through CLI, and in 2 seconds you can update your permissioning. And the reason this is important is because permissioning can be used, for example, to control attacks. It can be used to validate identity. For example, KYC or AML. If you can whiten list people that can actually interact with your network or not, which again, can be defined by KYC rules or whatever. And all that is important to kind of have a control over, right? And as I mentioned, it's also really node and account at a node and account level. So you can whitelist either accounts that interact with your smart contracts or with your node, or you can whitelist specific nodes. I have a whole presentation on permissioning, so if another day you'd want to know more about that, go ahead and tell me later on, and then we can talk about permissioning in detail. ConsenSys protocols. So basically, as I mentioned, there isn't just one ConsenSys protocol. The one that is used today in Ethereum public mainnet is ETH#, and it's proof of work. But then there's CLIC, which is proof of authority, and IBFT1 and IBFT 2.0, which, by the way, was implemented by our team, which basically give, again, these enterprises a way of, a ConsenSys protocol or mechanism that's going to be that's going to have a lot more throughput. So instead of 15 TPS, we're talking about 100, 150, 200 TPS. And it's not going to require their nodes to actually work for that proof, which gives us a really reliable security measure on a public network. But on a permissioned private network, we already know who interacts with the network. We already know who is part of that network. So we don't really need them to kind of prove security. We've proven that security through their identities. So by knowing their identities, we know who published what, and we can cryptographically prove that, right? So so that's kind of what proof of authority is, right? We know who is who. So yeah. So as I mentioned, you can use different ConsenSys algorithms in BESU by switching, one line in a ConsenSys, in the Genesis file. This is something that's interesting because we initially built BESU without a internal key management built into it. We thought it was a huge security concern to have your client also manage your transactions and your keys, basically your private keys. So we built them separately from the beginning. And interestingly enough, Geth and Parity have recently announced that they're also going to separate this now from in the future, in the near future. So you won't be able to sign transactions with your Geth client in the future, which is how we work. Now the way we work with eSigner, which is our the software we built to do this, is that we've made it compatible with as your key vaults and HashiCorp vaults in order to manage those keys for you. Kind of what I mentioned in the very beginning. We help enterprises interact with and more easily with the Ethereum network, right? Using tools that they already use today as key management tooling. Yeah, go ahead.
One question, what's the difference between eSigner and UPort?
All right, so UPort is an application that handles identity. So in that regard, I guess it's similar because private keys are basically identity. But in this case, eSigner, what it's going to do specifically is it's going to allow you to sign a transaction with your private key, and then that signed raw transaction, you can publish it onto the network. Okay, so it's much more low level than UPort. UPort is a very user facing dApp that helps you as a personal, as an individual, have an identity on the blockchain, whereas eSigner is low level, and it's going to basically cryptographically sign using your private keys a transaction for that signed key signed transaction already to be published onto the network. Does that make sense?
Yes, it sounds similar to MetaMask, but like lower level, right?
Same thing, yeah. It is similar to MetaMask because MetaMask does allow you sign transactions. That's how they that's what their dApp basically does. So each time you input your password into MetaMask, it decrypts your private key. I guess that's how it works. By the way, I'm not sure about this, but it decrypts your private key, and it uses that private key to sign transactions and publish those transactions onto the network through their, I don't know, through their own through their ways. I don't know how they publish these exactly. I imagine they have their own nodes running on their servers. Our thing is kind of separate because it doesn't, you won't be using our version of ETHSigner. I mean, our running instance of ETHSigner. This is something that you'll run on your computer. So it's, it's quite different. But yeah, as you said, it's lower level and it does have similar capabilities.
Okay, thanks.
Yeah, you're welcome. So yeah, also, I like talking about.
Philippe. I have a question. ETHSigner, is that, what language is that? Or what stack? Is it JavaScript, Java, C#, Golang?
Sure. So all of our stack is Java based.
Oh, gotcha. Okay.
We have a couple of things which belong to Pegasus Orchestrate, which is an orchestration software in order to deal with orchestration online through that's written in Go. But the rest, the whole Pegasus stack is all written in Java. So ETHSigner is also written in Java.
Okay, thank you.
You're welcome. And by the way, the reason we wrote BESU and ETHSigner and all these things in Java is because of that enterprise-focused, mindset. We know today that most enterprise developers are Java developers, and we want to make it easier for them to build plugins for BESU, for them to kind of tweak the code if they needed to, for them to actually just read the code if they wanted to, and for them, to also contribute to the project. So there's valid reasons behind that Java choice. It wasn't just, let's build this with our language of choice or our preferred language out there. In fact, I would consider myself more of a Python or maybe even Go developer more than a Java developer. But I do understand the reasons behind the Java choice, and I think it was even necessary.
No, absolutely. I agree with you on that front. Yeah, there's way too many, not way too many. There's a large population of enterprise developers that are very experienced in Java. So onboarding them is important for this movement.
I agree 100%. Yeah.
Can I ask one question? Can
Sure,
you hear me?
go ahead. Really, perfect. Go ahead.
Yeah. So the question is regarding ETHSigner. So basically, if I understood correct, so ETHSigner help you to sign remotely, separate your logic of signing from the BESU, right? But does the signer get the private key from the vault and sign it, or it delegates your raw payload to the signer, this vault, and vault does that?
So, okay, so first of all, it could be remote, but it could also be local. You could be running ETHSigner on your same machine as you're running your node. I don't know if that makes any sense, because I would rather have that separate if in terms of security concerns. And then, so yes, so is it, can you just repeat that last question?
So basically, I'm just asking whether the ETHSigner requires the private keys from the vault and then sign it, or it delegates just your request to the vault, and inside vault your signing happens and you get the signed payload back.
Sure. So yeah, I mean, there's going to be a point at one point you're going to need that private key, right? ETHSigner does need it. So ETHSigner does actually need that key, and it can recover it through key management services like HashiCorp or Azure Key Vault, etc. Or you could just have it on a text file on your server. Who knows? But yes, it does need that key in order to sign the transaction, and it's the signed transaction it sends over to BESU.
Oh, okay. But does that it has to be that way? So if you see, the vault should be handling the keys, and key never should be like never it should go out of the vault, right? Because I tried it with its signer with the Azure Vault also. It still, I guess, requires the key. I'm not sure. Like I have to do a little more hands-on on that, but
I see what you mean. I think it's a, sorry about that. Good. I think I see what you mean, and I think I agree with you. I'm actually not 100% sure if it. I mean, it does need the key for sure. I don't know how that's transferred to each signer specifically. I think it's a great question, and I might get back to you on that. Can you just maybe send me a quick ping on, I don't know, email or whatever, and I'll get back to you guys with a specific answer on how that private key transaction or processment works exactly. I think it's a great question. Thanks.
Sure. So you can, like, in the chat, you can mention your email or whatever,
Yeah.
Twitter handle, or like any chat handle where I can send.
I'll do that, yeah. Or I don't know how to do that actually. I'm looking for the bar here. It's felipe.faraggi@consensys.net. I'll write it later if I have some time.
Yeah,
but great questions about the ETH signer, everybody. I mean, it is something that's kind of difficult to grasp. I admit it's not something easy to understand. In fact, you know, Geth and Parity haven't like separated those concerns in all these years. So imagine how like difficult it was just for that to be something obvious. So just continuing, we only have 15 minutes left. So the GraphQL API is an interesting thing to mention because we built this through a bounty. We originally only had our JSON RPC API, and we created a bounty for, I think, 5,000 DAI, and it was built by external contributors through Gitcoin. So, you know, just maybe keep an eye out on our bounties through Gitcoin or otherwise. We also have security bounties at hacker1.com. So if you want to, like, if you're interested in security, just maybe take a look at that stuff. So monitoring, we have our, you know, BESU is integrated with Prometheus and Grafana today. So you'll have monitoring and alerting and a dashboard that's going to show all this. Again, super interesting for regular users, but really, really interesting for enterprise developers who need alerts on specific types of transactions that are going through the network. They need alerts for, you know, peaks or peaks in usage, who knows, I don't know. And all that you can create specific customized alerts for. We have like more than 200 of those like possibilities today listed somewhere. And it's really easy to use. We have this quick start on our docs. So that's besu.hyperledger.org. That's a link for our docs page. And we have this quick start guide with a Docker installation or basically it's Docker image that runs a network, a developer network on your computer, and it also gives you some endpoints for the monitoring data. So you can actually just click on basically run the Docker image and then click on a link and it'll show you this information on your network. So I recommend that, those quick starts if you want to check that out. So deployments, we also have.
Oh, sorry, Philippe. A question on the monitoring.
Yeah.
I mean, that's very subjective in terms of what different dApp developers want. They may want state, they may want to measure some sort of derivative monitoring thing. So is it configurable?
Yeah.
Prometheus, yeah.
Yeah, definitely. Did you mean the alerts specifically or the actual?
The alerts, like say I write a contract that I have to define what, you know, maybe some range of values of state. I would like to be able to define those to say, hey, I'm inbound, outbound, those kinds of alerts. Yeah,
exactly. Yeah, of course, these are customizable. Actually, Prometheus and Grafana are, you know, they're third-party open source projects, by the way. And go check them out because they're very flexible and you can basically tweak them to however you want. In this case, yes, you can modify and tweak those specific alerts and monitoring dashboards to whatever you want to show.
What's the DSL to configure it? Is it like JSON or?
Yeah, I think it is JSON. Yes.
Oh, okay, great. Thank you.
Yeah, so deployment, we run, we really care about CI and CD because we're like geeky engineers, I guess. But we also, use these in our solutions. So check those out. This is interesting because it kind of does an overview of what I've been talking about. So we have Hyperledger BESU with the private transaction manager, the key management here, and then the Pegasus Plus features with these specific permissioning, data encryption, private transactions, or specific private transaction features, more monitoring, etc. All that stuff up here. And in research and development, we have Artemis, which is our Ethereum 2.0 client, which I encourage you all to check out at some point. Again, also written in Java, interestingly enough. We have work being done on private side chains, cross-chain transactions, ZK proofs, all over. We have like meetings on ZK proofs all the time. So lots of R&D going on. Yeah, I don't think I'm going to go into the pluses features, I guess. So I might talk about this though, as a finishing slide, and then we'll leave it open for questions. So the reason I just want to insist on this, the reason we work with and we find it important to work with Hyperledger again, as I mentioned, is that we are committed to open source. We are fully committed to open source. That's kind of like the way we develop, really. It's a philosophy more than just kind of publishing code onto GitHub. Today, since we contributed the code to the Hyperledger Foundation, we actually stopped being the sole maintainers of that project, or rather, we're not the owners of that project anymore. Now, the actual official owners of Hyperledger BESU code base is the Hyperledger Foundation, and we've become the principal maintainers of that project, or at least some of the individual members of our Pegasus team are now on the maintainer list of that project. So if this is something that interests you in particular, really reach out to me. I would love, and we would all love to kind of diversify that maintainer list. Currently, there's 3 other people that aren't in the Pegasus project that are either a maintainer already or being voted as or for becoming a maintainer. Becoming a maintainer basically means that you have rights of accepting PRs and merging those PRs onto the master branch, basically. So if that does interest you, reach out to me. I think it's really important for us to diversify that maintainer list, and it does kind of exemplify why we're working with the Hyperledger Foundation, and we are the only like Ethereum mainnet compatible Hyperledger project out there. So that's all, everybody. Thanks for all those questions and your time. I guess I'll stop sharing now. Does anybody have any other questions? I see the chat has some stuff going on there. Oh, there you go.
Yeah, that's for me, I guess, asking questions. So does the Hyperledger BESU provide your dynamic addition and removal of the organization? Because as this is an enterprise level blockchain solution, so enterprises require that sort of thing, right? Organizations keep on adding and remove the organizations, and does BESU have that sort of capability to handle that?
Yeah, I'm sorry, Mandeep. I can't get that one word that you said. Is it automations?
No, the dynamic addition and removal of the organizations means you can sort of say as nodes. So basically, like in sort of enterprise level, like I'm a one bank, I'm transacting to another bank. So right now we are 2, but then we made a deal with the third one, and it came. So we interacted. It went out like sort of dynamic. Yeah.
So are you talking about like adding or removing validators or signers?
No, I'm talking about the participants.
Yeah. That's what I mean. I mean, you should consider, for example, in a consortium network, you should consider one participant being a node or several nodes, right? So that's what the validators are going to be doing, actually. So if you have a consortium, for example, you have each one of these participants have one node, and one of those, and that node is going to be a actual validator on the network. So they're going to be that validator is going to have rights to well, validate transactions and propagate them onto the network. So in order to add an additional member, you would have to add an additional validator, right?
And can I provide the sort of permissions also that to that member, for example? So I have so two organizations are interacting with some, and third one came as a kind of you know, we have sort of organizations on the upper level who is like governing body sort of, and in the later point, I need so that governing body needs all the rights and all. Can you provide that at that point of time, and later on when the governance is done, you can remove that?
Yeah, that sounds like what you're saying is very close to on-chain permissioning, in the regard that basically you change permissionings at one level and it applies to everybody, and then you, again, if you want to remove those, just change it on that one smart contract on-chain and it applies again to everybody. So yes, we do have that, and then again, there's other projects out there that do have or have implemented permissioning on chain, but it's a hassle because they don't have permissioning or permissioning like groups or privacy groups and all that, and that makes it much harder for them to update those rules. So yes, not only is it possible, but I think it's a bit easier than the one project I have in mind that does that already.
Okay, so that means that's a part of your Pegasus Plus.
No, I don't think so. I think that's part of the Pegasus BESU, for basically the Hyperledger BESU project, the main code base. We have a repo called permissioning smart contracts, I think, and that has like the docs section. You can check that out.
Oh, sure. So
github.com/PegasusENG or github.com/Hyperledger/BESU. Okay.
Yep. And one more thing. So,
Go ahead.
yeah, sorry to ask you too much questions. We are working on BESU actually. So give you just hands-on. So we are working on BESU. So we are working with the @signer and the deployer, the truffles and all. So my question is regarding: can you integrate the truffle deployer with the @signer to kind of deploy your smart contract by signed using @signer? And then sort of thing. That Truffle had the integration, or the BESU has it, I know, but does the Truffle has it?
So great question, super specific. Maybe, I don't know. I can get back to you on that as well. I think it really is an awesome question. So I know we work with Truffle specifically to handle private transactions, and we collaborate on that specifically. I don't know if we've worked with them on eSigner and how that could interact with their framework. If it's not the case, I would love to maybe explore that possibility with them. And with you, why not? I mean, as an open source project, right?
Yeah, sure. Not a problem.
But it is a great question. So I wrote that down. Any other questions I won't be able to answer?
Felipe?
Yeah, sure. Go ahead.
Where can we find the video that you did about the client architecture that you were showing us at the beginning of the presentation?
How about this? Because I don't know. I mean, I don't have it here like close to me. So how about this? Anybody who'd want more information about BESU, shoot me an email. The email is in the chat already, and yeah, no need for very verbose thing. Just say hi from Academy thing. You know, can you give me more info? And I'll send you a whole bunch of links with the important stuff, including that video.
Good, thanks.
Yeah, welcome. And by the way, regarding that video, today we have a version of that video that doesn't have really good audio. So we're thinking and planning on making another one. So you know, just bear with the audio. It's not great. It's a presentation which was recorded with, you know, a potato camera or whatever, and it'll probably be better like in a month or so, but it's going to be, you know, who knows when it's going to come out, that other video. So I'd rather you just take a look at the first video, and if you have any questions, just kind of shoot them at me.
Great.
Okay. Right. Maybe time for one last question, or else we'll call it a day. Okay.
I have a good question. It's regarding EA versus Hyperledger. They seem to be very similar in their open source approach to enterprise adoption.
Mm-hmm.
What are the main differences, and what guided your, say, focus to Hyperledger?
That's a great question. I think there's first of all, we work with both of them, right? And they do have like different purposes. They do have different methods as well. The EA was created by like initially, I don't know, 2016 by maybe 25 different big companies that wanted to use this and wanted to find specifications. That's kind of like one of their main goals, right? Whereas the Hyperledger Foundation is more about actually bringing blockchain technology on to companies and letting them use it, right? So it's not that we prefer one or the other. We work with both. The Hyperledger Foundation has given us access to like a whole panel of companies that kind of trust that brand name. Hyperledger is highly associated with IBM, which is, you know, itself something I'd say positive, because IBM does have like the positive reputation in general, and companies do trust IBM. So there's that, you know, so there's both strategic reasons why we would want to work with Hyperledger, but there's also like this whole community of developers that's already building on top of Hyperledger, and we wanted to kind of be part of that community. And also, I think maybe this is the most important thing. Once you're part of a foundation like this, it doesn't matter what happens to the company itself. The project will live on, right? So even if Pegasus as a company eventually kind of, you know, who cares, dies, or for whatever reason we don't exist in the future, BESU is still going to be able to be maintained by that open source community. So again, like philosophical reasons, strategic, like business reasons, technical reasons, development ecosystem reasons.
Yeah, gotcha. Makes a lot of sense.
They're quite different, I would say, although they both kind of focus on enterprise blockchain. Yeah. Anyways, I want to be respectful and mindful to everybody's time. It's 18:01 in the best time zone, and so let's call it a day or night or evening in my case. And I'd like to again thank everybody for your very thoughtful and interesting questions and your time. And for anybody watching this recording, again, just reach out to me if you do have specific questions, and for everybody here as well. If you have future questions, reach out to me. Be sure to join our chat if you want to learn more about BESU. So chat.hyperledger.org. You create a Linux Foundation account, and then you can go into that. And be sure to like follow our project and all that stuff. And we'd really love to get like external contributors onto the project. So commit, comment, issues, all that stuff. Anyways, I cut you off, Amal. Yeah, you're welcome. And thank you. Yeah. See you, everybody.
Yeah. Hey, he was really interesting, right?
Oh, hey. Yes, I thought it was interesting. I'm still not sure how like the about the actual application that they're doing, but yeah, the thing was interesting. Yes.
Yeah, and may I ask, like, what are you, like, what are we, should we try, like, trying to integrate Ethereum to companies, or try to make projects like smart contracts or new dApps, new applications?
Yeah, that's a good question. You mean as a focus for us developers, right? Like, should we do app or should we do like say backend enterprise integrations to the blockchain?
Yeah, definitely.
I don't know, man. Look, I think I kind of rather do dApps than do these obscure backend connections with 100-year-old companies. But that's just me. I don't know where the money is either.
Yeah, me neither. But I think it's better to go from zero and try a project from scratch than just it can be about adapting companies, but about
Are you?
digital transformation.
Where are you at?
I'm at the 7th module. That's what you're asking, right?
Geographically, I'm asking. My bad for the.
Okay. I'm in Spain, in Madrid. And you?
Oh, cool. I'm in New York City.
Cool.
And are you from Spain or where?
I was born in France. And you are you from New York?
I was born in New York City. Sorry, I was born in Dominican Republic.
Dominican Republic.
Yeah.
And you speak Spanish.
Yes. Sí.
Ah, pues podemos hablar en español entonces.
Sí, podemos hablar en español. ¿Y cuál es tu trabajo? ¿Tienes trabajo? ¿Estás estudiando qué?
Estoy estudiando esto de Smart Contract. Antes programaba Python para hacer simulaciones de estrategias de inversión. Y sí, y bueno, y estuve trabajando con JDA en una empresa de logística de programador y me lo pasé bastante guay ahí. Ahora a lo mejor voy a entrar en Morningstar, que es un data provider de finanzas como Bloomberg y Reuters.
Ah, sí.
¿Y tú?
Tienen data sobre energía, ¿no? También.
Tienen nuevos proyectos que recogen data sobre cualquier cosa, como energía, seguros, estadísticas. Y si tienen un data center y yo voy a trabajar en el data center, pues recogiendo datos y estructurándolos o limpiándolos. Sí.
Ya. Yo trabajo aquí en Data Science también, en Nueva York, para un startup, también en Python.
Qué bueno.
Pero quiero conseguir un trabajo en blockchain ahora.
Sí, más con Ethereum y todo eso.
Sí, más con Ethereum, algo más en el blockchain space. Ya la parte de data me cansó.
¿Qué es lo que estudiaste?
Yo estudié ingeniería en energías, lo que yo sé de programación ha sido online.
Genial. Sí, yo igual. Yo estudié Business Bachelor. Business Administration. Así que
Nice. Bueno, Cyril, te
encantado.
dejo, ¿eh?
Sí,
Un placer.
un
Nos
placer.
vemos por ahí.
Hasta luego.